Yeah, we'll answer these questions. Yeah, read the statements and tell me if they are true or false. The first one.
Only the first one is true.
Yeah. So 24 is 2 to the 4, 4 to the 8, 8 3 is 24. M into M is M cubed. N 5 times you see here. So the factors of this expression are given here is true. The factorization of 36 m square n cubed is 2 to the 4, 3s are 12, 12 3s are 36, m square, n square, not n cubed. So this is false. The second one is false. The first one is true, the second one is false because it's n squared, but here we have n cubed. The common factors of 24 m cubed n to the power 5 and 36 m squared n cubed. Common factors. So 24 and 36. What's the HCF of 24 and 36? Okay, so 24 is 2 to the 4, 4 to the 8, 8 3s are 24. And 36 is 2 to the 4, 4 3s are 12, 12 3s are 36. So common factors 2, 2, 2, 2, and 1, 3. So 24 and 36, these are the common factors, 2 into 2 into 3. M cubed, M square, M square. N to the power 5, n to the power 3. So n to the power 3, the least power. So we have 2, 2, 3, this is correct. 2 m's, correct. And 3 n's, correct. The common factors, 24 and 36, 2 2's and 1 3 is common, correct. And between m cubed and m squared, the least power is common. So m squared, so mm. And between n to the power 5 and n cubed, the least power, n cubed. So the last one is true. So the correct answers, first one true, second one false, true. Okay, we'll start writing from the next one. This is pretty simple to understand. Yeah, we'll start working from here, Chulu. Please work along with me, and if you have any questions, you can ask me. completed, children?
Yes, ma'am.
Just a minute, ma'am.
Yeah. Or you can directly write the formula. Breadth is equal to area by length. Done, children?
Done.
So nothing is very in block 21. I don't find anything that needs an explanation. Everything looks simple enough. Yeah, I think for this one, I told you I'll share the answers directly the other day. Okay, let's take a test on the same chapter, children. Factorization. Just give you some different questions. Block 21, I'll share the answers, children, straight away because I don't find anything, like so difficult for you because all of them look pretty simple. So let's take a test now. So we have to first divide the first term of the dividend by the first term of the divisor. 10x squared. I'll just get you started and you can complete it. So now we have to multiply 10x squared with every term in the divisor. So we have to multiply 10x squared with every term in the divisor. So 10x squared into 3x squared. 10 into 3, 30. X squared into x squared, x to the power 4. 10x squared into 2x. So plus 20x cubed. 10x squared into minus 4. So minus 40x squared. Now we have to change the signs. Plus becomes minus, plus minus, minus plus. Cancels. Now these are like terms. X cubed, x cubed. They're like terms. So you can simplify them. Minus 20 plus 11. Minus 9x cubed. Again, like terms. X squared, like terms. Minus 82 plus 40. Minus 82 plus 40. Take the new sign. So it'll be minus 42 x squared. And you can bring the remaining terms down. Minus 12x plus 48. Yeah, please continue, children. Okay, so you should have finished by now. So the next step will be minus 9x cubed divided by 3x squared. Which is minus 3x. So that's the second term in the quotient, minus 3x. Now multiply minus 3x with every term in the divisor. Minus 3x into plus 3x squared. So plus 3 into minus 3. See this one into this one. Minus 9, x squared into x is x cubed. and multiply this one with minus 3x. So it will be minus 3 to the 6 x squared. And now multiply this with this. So minus into minus plus, 4 3s are 12x. Change the signs. Change the signs. Cancels. Like terms, x square, like terms. Minus 42 plus 6. So it will be minus 36 x squared. Minus 12x, minus 12x. You should take the new sign. So minus 24x plus 48. Bring the term which is not used down. Now, again, the first term of the new dividend by the first term of the divisor. Minus 12. That's the third term in the quotient. Now multiply every term of the divisor with minus 12. So minus 36x squared. Multiply this with this. So it's minus 24x. And this with this. Minus 4 into minus 12 plus 48. Change the signs. You can see that the terms are the same with opposite signs. Same terms, opposite signs. 0. So the dividend is a multiple of the divisor, or the divisor is a factor of the dividend. That's not asked. You just have to find the quotient and remainder, but this is what we can conclude. Because the remainder is 0, the divisor is a factor of the dividend. The dividend is a multiple of the divisor. Yeah, next one. Yeah, try this, children. So how will you factorize the numerator? Will you Is it splitting the middle term or is it grouping? What do we do?
By group.
Grouping, correct. So we'll group the first two terms and the last two terms. We'll try if that works. So that trial you should do it in the rough column, but you can also make out, see here, you have, this is 7, right? So 7 4s are, 7 3s are. And again, 2 4s are, 2 3s are. So mostly it should work in the same order. Mostly it should work in the same order without rearranging. Because 7 4s are, 7 3s are. 7 4s are 28, 7 3s are 21. 2 4s are 8, 2 3s are 6. So mostly the same order should work. So the HCF of the first two terms, the HCF of 28, we are grouping the first two terms. The HCF of 28 and 21 is 7. And XY, nothing common. Between the letters, nothing common. Open a bracket. 7 4s are 28, X minus 7 3s are 21, Y. Close the bracket. Plus 8 and 6, 2 common. X square and X common. So 2x into 4x is 8x squared minus 3y, close, divided by 4x minus 3y. You should not cancel now. Complete the grouping process. So we have the same expression in both the brackets. Write that once, 4x minus 3y, and gather the remaining terms in another bracket. You can write 7 plus 2x, or you can write the 2x term first also. 7 plus 2x or 2x plus 7 divided by 4x minus 3y. Cancels. So this is the result. Okay, next one. Yeah, this is the question. So the rule is in the numerator there are two terms, and the rule is whenever whenever all the terms in the expression have something in common, you must take out the common factor. The expression in the numerator has two terms, And these two terms have something in common. What is the HCF of 45 and 405? I think it's 5. So 5 9s are 45 m square minus 581 n square. You need to find the HCF of 45 and 405. Find the HCF. That's the common factor, the highest common factor. Find the HCF of 45 and 405. It's 5. So take out the common factor. That's very important. Divided by, in the denominator also we have 3 common. M plus 3n. M plus 3n. I think my HCF is incorrect. Again, between 9 and 81, 9 is common. So 45 is the HCF. 45 itself is the HCF. You can see here, even after I took out 5, you can see 9 and 81. Again, 9 and 81, 9 is common. So 9 5 the 45 is the HCF. I did not find, I just. So 45 is the HCF. M square minus 45 tens are 450. 45 tens are 450. So 45 nines are 405. So 45 common, 45 into m square is 45 m square minus 45 into 9 is 405 n square divided by, in the denominator 3 common, m plus 3n. So you can cancel 3 ones are 3 15 times. Now 15. Now in the bracket, we have two terms which look like a the whole square minus b the whole square. A the whole square minus b the whole square. In the denominator, we have m plus 3. So a square minus b square is a plus b into a minus b. A plus b into a minus b divided by m plus 3n. Cancels. So the result is 15 into m minus 3n.
Ma'am,
Yeah.
how will plus and plus get cancelled, ma'am? M plus 3n and m plus 3n.
Yeah, m plus 3n and m plus 3n gets cancelled.
Okay, ma'am.
So you can take up each of it separately. You can factorize them separately. X square plus 7x minus 30. What's the sum? What is the sum, children?
7
7. Very good. The product?
minus 30.
Very good. Yeah. So 1 into 30 is 30. 2 into 15 is 30. 3 tens are 30. Yeah. 3 and 10 will give us 7. Because 1 into 30 will not give us 7, right? Because 1 and 30 will give you 29 or 31. 2 and 15 will give you 17 or 13. Because if you add, you will get 17. If you subtract, you will get 13. 3 and 10 will give you 7. So now fix the signs. Required numbers are, it's plus 7. So it should be minus 3 and plus 10. So x squared minus 3x plus 10x minus 30. So like this, you'll have to work the remaining two expressions also. You'll have to split the middle term and then divide. I'll give you 5 minutes. Please try. All the three expressions must be factorized by splitting the middle term. You can do it in one step straight away, meaning as it is given in the question, or you can take up the expressions like this separately, work in 3 steps, split the middle term, work in 3 steps, and in the 4th step, you can show the final answer. I'll also work along with you children, but you don't have to look at the screen. Take the question and you can try it by yourself.
And the question given, all the three expressions are trinomials that are not perfect squares. All the three expressions are trinomials and they are not perfect squares. Like you cannot factorize them using the identities a square plus 2ab plus b square or a square minus 2ab plus b square. So we know two ways of factorizing trinomials. When an expression has three terms, we know two ways. If it's a perfect square, we use the identities a square plus or minus 2ab plus b square. If it's not a perfect square, then we split the middle term. So here, all the three trinomials are not perfect squares. So we have to split the middle term by finding the sum and the product. So the three expressions work it individually, factorize by splitting the middle term. And then in the last step, put the factors, the final answers. So this was the answer for the first one, this one for the second one, and this one for the third one. You see some terms get cancelled. Yeah, please check. Yeah, we'll wind up the session with this one. So in an expression, whenever you find perfect squares, you must always check if any three terms can be of the form a square plus b square plus 2ab or a square plus b square minus 2ab. You must always check that.
whenever you have perfect squares in the expression. So here in this expression, you have three perfect squares, a square, which is a the whole square, 9b square, which is 3b the whole square, and 4c square, which is 2c the whole square. So whenever you have perfect squares in the expression, you must always check if any three of them can be written of the form a square plus or minus 2ab plus b square. Okay, so now this one is minus, I told you the other day, b square is always positive. It's either a square plus b square plus 2ab or minus 2ab, but it's always a square plus b square. Only the 2ab sign will be plus or a minus. So it's always a square plus b square plus a square plus b square. So see here, this is plus a square, this is plus 9b square, this is minus 4c square. This is minus 4c square. So this one cannot be one of those three terms. Because it's minus, it should be a square. The two perfect square terms are always positive. It's always a square plus b square. It's plus 2ab or minus 2ab, but the a square and b square terms are always positive. But this one is negative, so leave that. So now we'll try to group these three terms. We'll try to group these three terms. See, we have two perfect squares with the, like appropriate signs positive, both are positive. And this one is minus 6ab. The middle term, it's negative. Okay, so we'll write this as a the whole square plus 3b the whole square minus 2 into a into 3b. Minus 4c square can be written as 2c the whole square. Now you can see that the first three terms are of the form a the whole square plus b the whole square minus 2ab. You can see you're getting 6ab. 2 into a into 3b, 6ab. So it's perfectly of the form a the whole square plus b the whole square minus 2ab. Or you can say x squared plus y squared minus 2xy. So which can be written as x minus y the whole square. So these three terms can be written as x minus y the whole square. Minus y because it's minus 2ab. So x minus y the whole square minus 2c the whole square. Now again, this is like a difference of two squares. This is like x square minus y square. X the whole square, it's like x the whole square minus y the whole square, which can be factorized as x plus y into x minus y. X square minus y square is x plus y into x minus y. So x the whole square minus y the whole square. That means this is x, this is y. X is a minus 3b, y is 2c. X the whole square minus y the whole square is x plus y into x minus y. All right, we continue here. So x the whole square minus y the whole square is x plus y. This is x, this is x plus y into x. This is x minus y. This is the final answer. I think I can write it here itself. X plus y into x. This is x minus y. Take down, children.
Yes, ma'am.
Yeah. Done, all of you?
Yeah, ma'am.
All
Done,
right.
ma'am.
Yeah. All right, children. So that's it for today's session. The answers to block 21, I promised I'll share it by today in the last class, but I haven't but I'll definitely make sure that I share all the answers to block 21 by the next class at least. All right. All right, children. So that's it for today's session. Thank you. You may leave the call. Good night. Harsha and Yarni, please stay back. Yeah, others can leave. Harsha, Yarni, please stay back.
Thank you, ma'am.
Thank you, children. Thank you.
Thank you.
Thank you.
Thank you, ma'am.
Thank you. Good night.